Welcome to my YouTube channel. Our topic today is a theory of quadratic equations. We are going to take some definitions. A quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a, b and c are constants with a not equal to 0. These equations can be solved using either factorization method, completing the square, or using the quadratic formula, which is x equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Let's take some examples. We should solve the following quadratic equations: x squared minus 3x minus 4 equal to 0. Number 2, 3x squared plus 2x minus 7 equal to 0. x squared minus 6x minus 10 equal to 0. So the first one, we are going to solve it using factorization method, and that is what we have there, that x squared minus 3x minus 4 equal to 0. We are going to look for two numbers such that when you multiply them you get minus 4, but when you sum them up you have minus 3. So those two numbers are 1 and minus 4, and you put it in the middle there. It will now help you in the factorization, and we now have x minus 4 in bracket x plus 1 equal to 0. Therefore, the roots of the equation will now be 4, or x is equal to minus 1. Solving I using quadratic formula. In this case, you are going to identify your a, your b, and your c. So our a here is 3, b is 2, and c is minus 7. So applying that formula, x equal to minus b plus or minus square root of b squared minus 4ac over 2a. When you do your substitution properly, you're going to have minus 2 plus or minus 2 square root of 22 over 6. Now, the roots of the equation are 2. The first one is minus 1 minus square root of 22 over 3, or x equal to minus 1 plus square root of 22 over 3. This is what we mean by applying quadratic formula. The third is completing the square method. How does that one work? The completing the square method says you should identify your b, divide it by 2, square it, and add to both sides. That's what he said. So in this case, our b is minus 3, our b is minus 6, divide by 2, you have 3. Then when you square it, you have minus 3 squared, which is 9, and you add it to both sides. You are going to have s squared minus 6s plus 9, and you are going to have equal to 19 on the left hand side. Now, the left hand side will now become a perfect square because it's s squared minus 6s plus 9. That is the idea behind using the completing the square method. And when you factorize it, you're going to have x minus 3 all squared equal to 19. So therefore, x minus 3 will be equal to plus or minus square root of 19. Therefore, x is equal to 3 plus or minus square root of 19. The roots of the equation are x equal to 3 plus square root of 19, or x equal to 3 minus square root of 19. Remark, it is not all quadratic expressions that can be factorized as two linear factors. Remember that the test for availability of factors with ax squared plus bx plus equal to 0 is to calculate whether b squared minus 4ac is a perfect square. For example, if you are asked to factorize x squared minus 6x minus 4 equal to 0, where your a now is 1, b is minus 6, and c is minus 4, then you calculate b squared minus 4ac to give us 52, and 52 is not a perfect square. Therefore, that factorization, that quadratic equation is not going to have simple factors. So this is one of the tricks in using to find out whether a given quadratic equation can be factored easily or not. Now, sum of roots of alpha and beta. If we call the roots of the equation ax squared plus bx plus c equal to 0 as alpha and beta, then alpha will now be minus b plus square root of b squared minus 4ac all over 2a, while beta will be minus b minus square root of b squared minus 4ac all over 2a. And their sum will become minus b over a, while their sum here minus b over a, and their product will be c over a. This is how we generated it, from first principle. Alright, so let's look at some examples. Given that a alpha plus beta is equal to 5 and alpha beta is 2 over 3, find the value alpha minus beta all squared. Solution: let alpha minus beta all squared be equal to alpha squared minus 2 alpha beta plus beta squared, which is equal to alpha squared plus beta squared minus 2 alpha beta. But alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha beta. Now, what will alpha minus beta squared now be? Is going to give us alpha plus beta squared minus 4 alpha beta. So when you substitute the value for alpha plus beta and alpha beta, you're going to get 22 whole number 1 over 3 as the answer. Now, going forward, let's consider the general equation again with solutions x equal to alpha and x equal to beta as roots of the equation. Expanding the brackets, you're going to have x squared minus x in bracket alpha plus alpha beta equal to 0. And also giving the equation and dividing through by a, you're going to have x squared plus b over ax plus c over a equal to 0. This is exactly what we got ab initio. Now we want to use this to find some solutions to some problems. Example: find the equations for the following. Find the equations for the following. A, the sum of root is 4 while the product is minus 7. B, the sum of root is minus 3 over 5 while the product of root is minus 1 over 2. Solution: if the sum is 4 and the product is minus 7, then the general equation is x squared minus x in bracket alpha plus alpha beta equal to 0. And when you substitute properly, you're going to have x squared minus 4x minus 7 equal to 0. For B, similarly, you do the same, and when you substitute properly, you're also going to get 10x squared plus 6x minus 5 equal to 0 after proper simplification. So that is how this one works. These are the two equations from the two problems. Thank you for watching.